want to find the product, 13 times 24. Now, I'm going to actually go through several modifications of this thing so you can see how we work with it. First of all, without storing the values, and then with storage, and then I'm actually going to change it to where it's minus 13 times 24, and then we'll see what kind of time we may have at that point. It's still loading personal settings. Okay, here's the idea. Since we don't have a multiply instruction on this thing, we have to somehow or other figure a way to do it. Well, I can do this. I can take 24 plus 24 plus 24, 24, 13 times. Okay. Royal pain in the neck. So let's try something else. Notice, let's just give this thing a variable name. Adding that thing to itself gives me actually 2 times 24. Now if I add p to itself, that actually gives me 4 times 24. Add q to itself, and I get 8 times 24. You see, that's a whole bunch fewer additions. I have 1, 2, 3, 5. 5 additions instead of 13. So that's the strategy that I'm going to use to come up with that. Computers, don't you love them? It has been loading my personal settings for several minutes now. Okay. So that I can use the board, I'm going to shut that down for a while here. So if we look at our instruction set back here then, we can figure out a way to do this. First of all, I need to get that 24 loaded. Well, you remember we had this this trick where we're going to do an AND operation with a register, an immediate operand. AND is opcode 5. I'm going to put this in register 0, so there's my destination register. I'll also use it as a source register. And then the next bit, being a 1, says that this is an immediate operand. And the last 5 bits. Okay, the intent of that is to clear register 0. Now, I want to get a 24 into register 0, again, without storing that value someplace, so I'm going to construct it. I'm going to do it in this manner. I'll use, first of all, the add instruction in immediate mode. Add is opcode 1. That 1 in that bit there says immediate mode. The number I'm going to add is 12. Remember, I can't get all the way to 24. Biggest number I can get is 15. I could do a 15 and then add a 9 onto it in immediate mode, but I'm going to do something here a little bit different. So I'm going to take register 0, add 12 onto it, and put it into register 0. Okay, that puts a 12, which is C in hex, in register 0. Now the trick is I can now get 24 just by adding that to itself, rather than doing another immediate mode kind of thing. I'm going to take register 0, add to register 0, remember, when you do add in register mode, you've got these 3 zeros in here that are just there, and put the result into register 0. Okay, so I just add that register to itself, and that gives me what I'm looking for. Something is totally hung up here. Because it's still loading personal settings. Well, I may not be able to show you how the thing works. I can't even turn it off. I'm gonna have to pull the battery out and shut it down. I have to do that and try and reboot it. Okay, I've got a 24 into register 0. Now, using this kind of a strategy, I'm going to generate this P by adding register 0 to itself and put it into register 1. Now, as I finally found my 13 times 24, I didn't need that one. I don't need 2 times 24, I need 8 and 4. Okay. I can do this. I can take register 1 plus register 1. And since I don't need that value, I'll just put this back in here. So now register 1 is actually going to be equal to 4 times 24. And now I need an 8, so I can get that by taking register 1 plus itself, and we'll put it into register 2. So now register 2 is 8 times 24, 96 plus 96, or 192. Get anywhere with them. Now, see if it'll boot again. Okay. We now have 8 times 24, 4 times 24, and 1 times 24. So now all I need to do is accumulate those things back into here. So I will I'll now add register 0 plus register 1 and put the result into register 0. So now register 0 is 0 plus register 1. Register 0 has 24 in it. Register 1 has 4 times 24. So I've got 4 times 24 plus 1 times 24, or 5 times 24. And now I will take what's in there and I will add register 2. 2, 1, 0. This is all in binary. Register 0, register 2, so now register 0 is register 0 plus register 2, which is 5 times 24 plus 8 times 24, or in other words, 13 times 24. And that's the end of our program, so we will use the halt instruction, or the trap instruction. It works out to be a halt. Opcode 15. The next 4 bits are all zeros. And then for the halt, we want 2, 5.
Is that just something we need to know? Is there?
That's just the way you end the program. Yep. Okay, now, as we go to enter this thing in, there are actually 2 pieces of the LC3 system. There's an editor and the LC3 simulator. This is the thing you use to generate the code in the first place. And really what we'll do is we'll just enter this stuff just as it is in binary. But there is one other thing that you have to be aware of. The first line that you enter, the system will interpret as the starting address of your program. So if I enter this thing just like it is, it's going to load this thing at location 5020. X. And that first instruction won't be there. So we have to have a starting address up here. The default that the system kind of likes is this one, hex 30, no, not 300, 3000. As is typical of these kinds of systems, the low-numbered addresses tend to be used by the system, and high-numbered addresses generally reference I/O devices. And so you like to stick in the middle somewhere. And as long as you don't use too many memory locations, this works out fine. Okay, so that's the first line that you would put in there.
If we've already been playing around with it, can we start somewhere else?
Yes. You can. You want to be a little bit cautious about some of the other locations. Okay.
Takes a while.
Okay. Now, there really isn't anything magic about the 3000. It's just, like I say, that's kind of a default within the system. It kind of likes to start there. The system keeps telling me presentation mode is off. I don't know if we're going to be able to get this up there where you can see it or not. Brings this thing up, it doesn't give me enough time to do anything with it.
So are you just looking to use the LC3?
Yeah.
I'll volunteer my computer to do that.
Can we get it hooked into where it'll talk to this thing? I've got the system up on mine, but for some reason or another, it won't communicate with the projector. Let's see. Oh, yes. These. It should be function FA. Let's see what.
Okay, let me make the same for the projector.
It's what?
The automatic there.
It should be.
Samantha's computer.
it's stuck, just shit.
Yeah, we just keep key.
Well, no, this is,
Try pushing Windows keep key on your computer.
Well, my computer is showing that it's set on duplicate right now.
yeah,
There you
well,
go.
that's what mine showed too, but I
Voila.
couldn't get it to. Okay. Let's, now, let's see. I've got all this code across here, but we'll just regenerate it as we bring it up. And hope we get about the same thing out of it. Okay. This is what the editor window looks like. It's pretty bare. You just put it in. Okay, our first entry is our starting address. I will use the 3.
If you put spaces in your bit sequence, does that screw up the editor?
I haven't tried that. I've always figured, yeah, I better do it this way. Might be worth trying just to see what happens.
I thought it ignored them.
It may. We'll play with it here and see what happens. The first instruction I had was an AND. Which is opcode 5. I was working with destination register 0, source register 0, a 1 to indicate that it's immediate mode, and then 5 zeros.
We're gonna clear the register.
It's what?
Are we gonna clear the register first?
That's what this instruction's doing.
Just test it.
Okay, remember the opcode 5 is a clearance, is an AND. And I'm ANDing register 0 with the immediate value 0. Okay, so that clears it. Now, the next instruction that I worked with was to load a 12 in there by adding 12. 0001 is the add instruction. Register 0 is where the result's going to be. Register 0 is where I'm starting from. A 1 here says immediate mode. No, we've got one too many zeros in there. My immediate operand is the last 5 bits. 1100 is a C or a 12, and so that gets a 12 then into register 0. The next step was to add those two, add 12 to itself so that I've got a 24. So now this instruction will be a little bit different. It's register 0. Remember, the first one is the destination, the second one is the one you're starting from. Then in register mode there will be 3 zeros there, and then the other register that you want to work with. So that adds register 0 to register 0, adds these two registers together and puts the result in this register. So that gets my 24 in there. You'll be able to watch this as we go through and execute it. Now, I added register 0 to itself and put it in register 1. So we have add. Now you see my result's going to go into register 1. And I'm adding register 0, my 3 fill zeros, and the other register. Adding register 0 to itself and putting it into register 1. Okay, so if we just kind of track things along here, this puts register 0 to be a 12. This makes register 0 24. This makes register 1. I'm going to leave it as 2 times 24. Here's my destination. I'm adding these two things together. Okay, now I didn't need 2 times 24. I need 4 times 24. So now I add register 1 to itself, and put the result in register 1. So now register 1 is 4 times 24. Now, I'll add register 1 to itself to get 8 times 24. And put that into register 2. So now you see register 2 is 8 times 24. We'll actually execute all of this stuff and you'll be able to track it through and watch it actually happen. So now I've got 8, 4, and 1 times 24. Those are the things I need. So I will now add, I'm going to collect this down into register 0, so my destination register is 0. I will add, let's see, first of all, let's add register 2. So now I take, here's register 2, and register 0 goes into register 0. So register 0 equals register 0 plus register 2, which actually gives me 9 times 24. And now I'll add register 1 into that sum. So now you see, here's register 0. That's where the result's going. It's register 1 plus register 0. Register 1 is 4 times 24, and 9 gives us 13 times 24. Okay, so that's where we wanted to end. So now we'll enter our halt instruction. 4 1s followed by 4 zeros, and then the 2 5, 0 0 1 0 0 1 0 1. Okay, that's trap X25, which is a halt. This this thing up here, just as a note, is starting address. And the purpose of this one was to clear register 0. Okay, there's our complete program. Now, here's what you have to do with it at this point. If you look up here, we have this little thing that says translate. Well, I'm not translating, it's already in machine code, yeah. But it does some preparation, some packaging of this stuff to get it so that the simulator can run it. Okay, things that don't have anything to do with the program, but do have to do with the simulator. So we come up to there, and it says convert base 2. That's where we are. We wrote the thing in base 2. You can also write them in hex. Each line would have to contain exactly 4 hex digits. If any of your lines here contain fewer than 16 binary digits, it won't accept it, or more than 16. Each line has to have exactly 16 binary digits. This thing generates what's called an object file. Where do you want me to put this?
No, you just put it on the desktop, that's fine.
Okay. Let's see. First, I've got it in binary. Okay. Gives us this little message down here. It says it's converting it from base 2, convert complete, no errors. In other words, everything that I typed in there was
You actually have to put the file extension on
acceptable.
there when you save it.
What?
You actually have to put the file extension on there when you save it.
You know, the instructions say, please use the correct file extensions. In other words, you probably wouldn't have to, but the system works better if you do. Okay, now having done that, we're through with the editor. So I'll close the editor down, simulate. Okay, when the simulator comes up, this is what the window looks like, and you can see this default. This is the memory location that it comes up with. Now, I need to load that program. You go up here to File, and Load Program. And it should be on the desktop. There it is right there. And we say open. And now all of a sudden, here's my program. Notice that here's the binary code that I typed in. It has actually translated it into hexadecimal. It has also given me the mnemonics that we'll talk about later on, but you can see that. But here's what we wrote right in here, right down to here. Now, another thing to look at, notice here are the registers. Here's the program counter. It's set to execute the instruction at 3000. There's nothing in the instruction register. This is the processor status word, and these are the condition codes. watch those as we go through and see what happens to them. Okay, now, one of the nice things about this system is this step over thing. What it actually allows you to do is go through and execute the program one instruction at a time. And you can see what happens to it as you go. Okay, notice that it executed the first instruction. See that big blue arrow? It's now ready to execute this. See how the PC changed? Register 0 didn't change because it already had a 0 in it. But the intent of that first instruction was to be sure that it did have a 0. Okay, now I'm wanting to add 12 onto register 0. Let's see what happens. F10 is the stepper. So when I press F10, now all of a sudden you see I'm down to this instruction, and sure enough, there's my 12 in register 0. Now I'm going to add register 0 to itself, so I should end up with a 24 up there in that register. And I do, 1/8 in hex or 24 in decimal. Now we're going to put something into register 1. It's 24 plus 24, so I should get a 48 in there. See what happens. Sure enough, there it is. 3 times 16 is 48. So there's my 2 times 24. The next instruction doubles that, so I should end up there with a 96. Which I do. 6 times 16 is 96. Okay, so there's my 4 times 24. Right there. The next instruction should double that and put it into register 2. Now register 2, notice 96 and 96 is 192. There's my 8 times 24. Now then, I want to add register 2. Here's register 2 to register 0. Put it back in register 0. So I should get 192 plus 24, which is 216. Back in there. See if I can do that arithmetic in my head. There we go. So now my register 0 contains 9 times 24, and I'm ready to execute this last instruction, which adds register 1, another 4, which gets us up to our 13 times 24. 312, let's see, 24, 13. That's right. 312.
You add a console with it.
Is what?
Unless you add a console with it. That's if you add it.
What about it?
Let's see if it was.
We'll have to shut this down and bring it up, but hang on for a minute. So now we're down to the last instruction, which is a halt. And what it actually does at that point, we didn't talk about the condition codes as we went through. Notice that it ended up with a P. Add instructions always change those condition codes. P means that the result of the last add, or any other like it, was positive. And yeah, that agrees. Now, it jump, you see, to someplace. What that someplace actually is part of the simulator that handles the halt. It basically shuts things down in an organized way. Okay, so that's why we ended up in a weird place. You can actually go up and do a jump to and go back to the beginning and execute it again. Watch what happens. Let's see. Here's something interesting. If I go back to 3,000, ready to execute the thing, let's see what happens here. Oh, it keeps jumping down into there. I want to go back and start the execution again.
Program counter button, little blue arrow.
The little blue arrow isn't getting set, that's why it's not
Yeah.
working.
So if you.
Yeah, that's the thing that's going on, is that this value up here is not being changed.
If you click the blue arrow at the top, it will.
Yeah, if you jump to back to the hex, 3,000, and then click the blue arrow right there.
That puts my program counter back where it was. Now, just notice that as I begin at this point, register 0 does not have zeros in it. So what does that first instruction do?
So, set it back to 0.
Aha. All of a sudden, register 0 has zeros in it. Okay? That's an example. I was hoping we would have time to do more of that, but anyway. Now, you wanted to see the editor window again. Was there something in particular?
Yeah, could you open up the file that we just wrote?
I'll see if I can.
I have all the code from that file just right behind it there that I don't have.
There it is.
Can we check if it works with the spaces?
It does.
Oh,
It does?
It
Every time I
does.
see just a wall of zeros and ones, I get confused.
I think
It's
it
also put
ignores.
a colon at the end and put comments,
It's easier to find it.
semicolon.
let's just go that far and see what happens if we translate it. It'll take it on the first instruction. Looks like it's okay, it didn't give any kind of an error. Yeah, it does help. Binary numbers strung out that long get to be pretty hard to work with. Anyway, here's your assignment.